Hi everyone, good morning. Welcome to Gnan Cloud Garage. So VMware NSX-T 3.2 and today we are into the session 2. So session 2, I'm going to focus on difference between NSX-V and NSX-T and migration options from NSX-V to NSX-T. And here is the today's agenda. What is a VMware multi-cluster and multi-cloud strategy, and why do we use VMware NSX, and how does VMware NSX work, and NSX-T virtual network services? What will happen when we have NSX and without NSX? That means if no NSX, what will happen? We can observe today. And how is the VMware NSX license options, and what are the use cases for VMware NSX-T, and what is difference between NSX-V, NSX vSphere and NSX transformers, and architectural comparison between both NSX-V and NSX-T, and product lifecycle of NSX-T data center for vSphere, that is in short form NSX-V, and what are the migration options from NSX-V to NSX-T. So let's start with our recap points. So what is the VMware multi-cluster and multi-cloud strategy? The life cycle management of modern applications. Modern applications currently it's running in a development process called DevOps. That means development and operations. And applications also architecture has changed from monolithic to tier-based architecture and tier-based architecture to our latest architecture, which is microservice architecture, and all are running on a container and microservice applications. These are all the modern application. This modern application consisting of 5 phases. Phases are first phase is build, second run, and third one is manage, connect, and protect. The first 3 phases build, run, manage. Tanju plays a big part in build, run, manage. And NSX is a critical part of VMware's multi-cluster, multi-cloud strategy for connect and protect. Okay, so see the 5 phases of modern application: build, run, manage, connect, and protect. The first 3 phases is focusing on VMware Tanzu is the main portfolio to cover the modern applications first 3 phases. And the connect and protect, we have to use VMware NSX. NSX means N means network virtualization, S means security, X means any platform. So network virtualization and security platform you can run on any platform like on-premises, private cloud, public cloud, and multi-cloud. And network virtualization mainly focused on the connectivity portion, and the security is mainly focused on the protecting your all workloads. Okay, that is importance of VMware NSX. And this NSX can run on VMware platforms like VMware on-premises, VMware private cloud VCF, and you can run on VMware hybrid clouds like VMC on AWS, and also you can run on multi flavors of public clouds like AWS, Azure, Google Cloud, IBM Cloud. Anywhere you can run NSX supported for all workloads. Okay, that is a one key point. This point we covered in the previous session. I'm just recalling. Okay, and let's move on to the another point. This is also recap. Just recall, why do we use NSX? One main important point here is, let's talk about there is a two scenarios. Scenario one, same ESX host, and scenario two, host to host. That means one ESX to other ESX host. Let's talk about the scenario one. Suppose in the scenario one, we split it into two parts. First part explains about before NSX. That means there is no NSX, and second part refers as a with NSX. Let's try to understand before NSX portion. And here in this diagram, we have the components. See, we have two virtual machine. One virtual machine is web tier VM, another one is app tier VM. And web tier VM IP address we given as 10.1.1 network. And in the second one, second app tier VM, 10.1.2. That means both networks are different networks, different network subnet or different segments. So this VM1, if you want to communicate from VM1 to VM2, but both VMs are running on our same ESXi host. Even though if it is running on same ESXi host, the connectivity processes within our ESXi host, we have virtual switch or distributed switch. From the ESX, we can have a network connections. Two network ports are connected. One network going to one switch. Fabric A means fabric is nothing but a network device. So here in this diagram, fabric A refers as a switch A. So from the ESXi host, connection connected to switch, from switch to it connected to router. And same way fabric B also connected to CSXA host. Fabric B also have a connection to multiple routers. Suppose in our scenario, if we want to communicate from web tier VM to app tier VM, the communication will start from virtual machine to ESXi physical NIC and ESXi physical NIC to physical switch one hop, and physical switch to router second hop, and again that it will return to the switch third hop, and switch to it will return to the virtual machine fourth hops. So that means in order to communicate from within the ESXi host one segment to another segment, or one web VM to app VM, the communication will take place as within a four wire hops. Four wire hops, its explanation is refers only for a one virtual machine. Same way, one virtual machine communication to another VM. And same way, if we have a NSX, NSX means Network Virtualization Security Platform. When we are using NSX, here also same scenario, two virtual machine, web tier VM, app tier VM. But instead of within our ESXi host, we have another abstraction layer, that is NSX. This NSX is running with a logical switch. When we have a NSX logical switch, if you want to communicate one VM, web tier VM to app tier VM, we no need to go to the connection to the physical network. Within the virtual network, we can communicate from web tier VM to app tier VM. That means there is no wire hops, it's only zero hops. But when we compare the first scenario before NSX and with NSX, before NSX, the communication takes place with four wire hops, but here is zero wire hops. This explanation only communication between two VMs, web tier VM and app tier VM. Let's imagine in our organization we have hundreds of VMs or thousands of VM or more than thousands of VMs. Daily there will be so much communication establishing between our virtual machines. Our VMs like web VM, DB VM, app tier VM, all 100 VMs are more than 100 or 1000, more than 1000 VMs. Let's imagine if your hundreds of VMs or thousands of VMs want to communicate in between each other, there will be so much network traffic in your switch level and routing level, and the network hops also keep increase. One VM and two virtual machine communication, there is so much difference. Four wire hops. Can you imagine 400 VMs? 400 VMs means 4 into 4. It's almost 800 wire hops enhanced in the before NSX traffic. Traffic will be established, but with NSX, there is no much traffic when compared to before NSX scenario. So that's the reason we mentioned that communication never leaves the host with the NSX. That is the importance of scenario 1. When comes to the scenario 2, east-west layer means within the ESXi host intranet communication, we call it as east-west layer, that is layer 3, and routing is considered comes under the layer 3. And yesterday we talk about the OSA model. Layer 3 means it refers as a east-west network. Layer 3 means network only. And host to host means one ESXi host to another ESXi host communication. In this diagram, let's talk about before NSX. If I want to communicate from one VM, this VM is running on one ESXi host and another VM running on a second ESXi host. This scenario also, instead of going to the same scenario, VM communicate ESX and ESX to switch, switch to router, and router to its back to the switch, switch to the ESX, ESX to VM. Here also it will take the four wire hops. But when comes to the with NSX scenario, but here it is not within the ESX, it's a another ESXi host. The communication will start from VM to ESX NIC card and ESX NICs to physical network. That means when our VM is running on different ESXi host, destination VM, it required to connect to the physical network From the physical network, again, it's back to the ESXi host, and through the NSX logical switch, it's communicated to VM. But even the, if you compare the hops, before NSX, it was four wire hops, but in the with NSX, it's a two wire hops. That means reduce latency on network hops with NSX. So this is the main importance. Why do we use NSX? But this comparison, we are trying to understand between two virtual machine communication. But imagine if you have thousands of virtual machine, our network latency and traffic is definitely huge if we do not have a NSX. If we have NSX, the network traffic will be reduced and redundancy also reduced, and it will be a smooth operations in our network infrastructure layer. And so that our end result will be like we'll get the performance gains and eliminating hairpinning with VMware NSX. Okay, hope you understand this point. Okay, once we clear about this point, now let's back to the next point. Go back to the next point is how does VMware NSX work? Okay, even how NSX work is, if you try to understand the left side right side diagram, within our physical network we have switch, router, load balancer and firewall. Within this physical network we can have to install the network devices and IP transport network. But if you want to make this physical network to virtual network, in order to make the virtual network we have to install a virtualization software that is called network hypervisor. When we install the network hypervisor, that is NSX software, it will help you to decouple your network physical network device, and it will make it as a virtual network devices. So switch become as a virtual switch, and the router will become as a logical router, and load balancer will become as a logical router, and firewall will become as a distributed firewall. So the same points, that is how NSX work. The sub points are highlighted in the description. VMware NSX reproduces the entire network model in software, enabling any network topology from single to complex multi-tier networks, and to be created and provisioned in seconds and independent of underlying hardware. So it's not dependent on hardware, it's a completely independent of underlying hardware, and also can be provisioned. All the logical switches routers will be in within seconds, but physical scenario it's not like a seconds. Okay, and it brings network and security closer to the application wherever it's running. So closer to application means, let me explain you in the following slide. See, one of the most famous digital proverbs are, whatever you whether you want to go fast, sorry, whether you want to go fast or far, go together. This is a famous digital proverb. So from this digital proverb, we understand that whether you want to go fast or far, go together. Same way, our NSX also, it will go together with our modern applications. Like see, modern applications, networking and security with NSX-T going further and faster. When we verify our operations with virtual servers, networking and security, not only will be able to take our business further, but we also get there faster than ever before. Suppose in this diagram, our basic infrastructure layer is servers. On top of the virtualization ESXi, we are installing the NSX. NSX means it's providing a network virtualization and security. On top of the network virtualization security, we can install our production related modern applications. So with this benefit is go further faster with the software defined networking and security. Okay, now let's talk about NSX-T virtual network services. Like how in our virtual machine, when we create a ESXi host, install the ESX and create virtual machine, we are getting the virtual machine means it's a software generated machine. It's providing a all virtual components like vCPU, vmemory, vdisk and NIC. Same way, when you install a NSX on any virtual machine, ESX a virtual machine, or you can install NSX-T on KVM, you can install NSX-T as a bare metal. When we install the NSX-T, it will provide you virtual network services, same like our virtual machine providing vCPU, vdisk, vmemory, and vNIC. Same way, our NSX-T also provide you the virtual devices, which is logical switch, logical router, firewall, and load balancer. And let's try to understand understand the NSX-T virtual network services here. And in an SDN deployment, SDN means software defined network. Networking services are programmatically distributed to each virtual machine independently of the underlying network hardware. It offers distributed logical routers, logical distribute logical architecture for L2 to L7 services. So yesterday we talked about OSA model. It starts from layer 1 physical to layer 7 application. So when we install the NSX-T, it's providing all the virtual network services. It offers a distributed logical architecture for L2 layer 2 to layer 7 services. Okay, and layer 2 means data link to until the application layer services. And application workloads can dynamically added or moved, and all network and security services attached to the VM move with it and anywhere in the data center. So this network services can be provided wherever our applications are running, whether it can be in a data center or it will be in a cloud environment. And SDN means software defined network, allows data center administrator to treat their physical network transport layer. So physical network as a transport layer. And a virtual network provides logical network components to connect it to workloads. So these workloads, all our components are logical switches, logical router, logical firewall, load balancer, IPS, intrusion prevention system, and intrusion detection system, and more. Not only limited to these 5 services, we also have some additional services. Okay, let's talk about in detail now. NSX-T virtual network services going beyond just layer 2 operations. So within the layer 2 operations, the main key 5 network services are switching, logical switching, and this is the icon for switching. So let's start familiarizing these icons, and this is the icon for routing. So it's showing as incoming traffic, outgoing traffic. And firewall means we have a firewall, and intrusion prevention like our secret detective agents. This NSX also providing a IPS and IDS services, intrusion prevention system and intrusion detection system, same like our secret agents. And load balancing, detective agents, and load balancing also mainly to balance the load. This is the icon for the load balancing. Using one load balancer IP, it will distribute the load among your application servers. Okay, so when we familiar with the in-depth concept of all these services, we can become as a NSX-T virtualization engineer, network virtualization engineer. And in our later sessions also, our main core concept we have to learn in depth of logical switching, in depth of logical routing, logical firewall, logical IPS and IDS, and load balancing. If you're familiar with this 5 concepts, that is only the NSX-T complete concepts overview. Okay, so in this session, I will try to explain you the definition, and later session we'll start learning one by one. First, we'll focus on switching concept. Once familiar switching, we'll go for the remaining services. Okay, so switching in our virtual network, we call it as a virtual switching or logical switching. And routing also, we have a 2 types of routing. That means internet communication routing, and as well as intranet communication segment routing. Okay, 2 types of routing. Okay, and firewall also we call it as a distributed firewall. This distributed firewall in short form DFW. And intrusion prevention also we call it as IPS, intrusion prevention system, and IDS means intrusion detection system. And load balancing also, it will provide you load balancing from layer 3 to layer 7 load balance. These are all completely integrated security, and this virtual network service are going beyond just layer 2 operations. That is the importance of NSX-T virtual network services. Now let's talk about the definition of each component. See, virtual network services, logical switching. So within the logical switching, the main switching, how it will function is, it allows us to create multiple logical segments. Logical segment is nothing but a virtual networks. Like I have a one network is 10.1.1 and another network is 10.1.2. That means it's both are 2 different logical segments, or we can say logical virtual networks. to which an application can be logically wired. If you want to communicate between two different segments also, we require logical wiring through logical switching. So virtual switches are quickly deployed through software. So it's a software component, provide all characteristics of physical network broadcast domain VLAN. So it provides the same as a physical network broadcast domain VLANs without physical layer 2 sprawl or spanning tree issues. Okay, that is importance of logical switch. And a virtual switch is mapped to a Unix VXLAN. This VXLAN concept only in a NSX-V, and the latest NSX-T is updated the encapsulation protocol from VXLAN to GenEVA. GenEVA full form is generic network virtual encapsulation. That is a full form of GenEVA. So virtual switch mapped to the GenEVA, which encapsulates the virtual machine traffic and carries it over the physical IP network. That is the importance of logical switching. Now let's try to understand the routing. So within our virtual network service, second main component is distributed logical routing. In short form, we call it as DLR, distributed logical routing. See this icon, let's try to familiarize this icon. When we have this icon, just understand this, it's a router icon. And DLR, the implementing logical routing functionality allows a hypervisor to learn and route between different logical network. If we have a same logical network, our switch is enough. If we have a different logical network, we require a DLR by limiting the north-south direction of traditional data center routing. And NSX-T data center supports different gateway TS, that means logical routers for different purposes. So there is a two different type of logical router. One router is called as tier 0 gateway, another type is tier 1 gateway. So tier 0 gateway provide north south connectivity and tier 1 gateway provide east west connectivity. So now let's try to understand the right side diagram. Suppose in the right side diagram it says that NSX-T data center and we have a virtual app. Virtual app means grouping of multiple virtual application servers. So this we have grouping of VMs, grouping of VApp, grouping of VApp, but each this group of virtual machines connected to one segment, that means one logical virtual network, and this icon refers as a logical switch 1, and another network connected to logical switch 2, another group of VMs connected to logical switch 3. So if you want to communicate within your logical switches within our intranet communication, that is called east west routing. For the east west routing, it's clearly mentioned that tier 1 gateways provide east-west connectivity. So even in this diagram, see tier 1 gateway will provide a communication between within your logical segments or within your logical switch different virtual network. If you want to communicate within your intranet, it requires a tier 1 gateway logical router. That is the point here. Suppose from the tier 1 gateway, if I want to communicate it to the external world, that means internet communication, we have to connect tier 1 to tier 0 first, and tier 0 will help for a north south routing from our intranet connection to, if you want to go to our external communication, external internet world, the main communication will established from tier 0 gateway. That points we highlighted here. Tier 0 gateways provide north south gateway and tier 1 provide east west connectivity. So that is the importance of DLR, distributed logical routing. Okay, so in detail concepts we'll discuss in the following sessions, but here try to understand the description of DLR, the basic definition and description. Now let's talk about another point, which is distributed firewalling. So this distributed firewall also, short form we call it as DFW, and icon also it's showing as fire with firewall. So this is the distributed firewall, wall with fire. Okay, firewall icon. And distributed firewalling, making the decision to move away from perimeter centric security to VM level protection, was not easily achievable prior to NSX. So it was not easy before NSX. And rather than persisting with traditional per data center level firewall protection, logical firewall provide per VM level protection. So earlier it was like not like a per VM, but when we are using DFW, it's providing a per VM level protection. And firewall policies can be created and easily deleted with just a few clicks. Okay, and policies are configured at the VM level and therefore follow the workload it moves between the hosts within the cloud foundation environment. So the firewall is configured individual VM level. You can migrate the VM within your, either you can keep it in on premises or migrate to another cloud like a private cloud or public cloud. We can move. Okay, that flexibility we have when we are using a distributed firewalling. Now, another key component in the virtual network service is IPS and IDS, intrusion prevention system and intrusion detection system. This is also we consider as distributed IDS. Okay, this distributed logical names are familiar when we are using a NSX. IPS functionality adds additional traffic inspection capabilities to the service defined firewall, and the pillars of IDS and IPS functionality are the regular expression engines that detect traffic patterns, and these engines programmed to look for a known malicious traffic pattern using configuration language. That is the importance of IPS. And NSX co-locates the IPS IDS functionality with firewall, leading to a single pass design for traffic inspection. And all traffic passes through a firewall first, followed by IDS IPS detection, and depending on the configuration. So first it will go to the DFW, and then it will followed by this inspection, and then depending on our internal configurations. And this co-location of IDS IPS functionality with the firewall also simplifies the expression and enforcement of network security policies. Okay, now let's talk about the another key component, load balancing. So load balancing means NSX Edge. We have to, apart from our NSX-T installation, we have to install the NSX Edge. This NSX Edge offers a variety of network and security services, and a logical load balancer is one of them. When we install NSX Edge, one of the services is load balancing. So NSX Edge gateways interacts logical networks with physical network. This means virtual machine connected to a logical network can send and receive the traffic directly to the physical network through the gateway. And a NSX and NSX Edge gateway provides perimeter services such as DHCP, Dynamic Host Configuration Protocol, VPN service, Virtual Private Networking Service, dynamic routing, that means automatic routing, static routing, that means manual routing, NAT, network address translation, firewall, load balancing, DNS relay, and high availability. These are all features we can get it when we configure a NSX Edge gateway. Okay. Now let's talk about the another point. What will happen when we have NSX and without NSX? Okay. Let's observe the both scenarios. Let's say the scenario one, we have VMware NSX, and NSX supports for virtual machine, containers, and bare metal. You can run the NSX on anywhere. Either you can run on ESX VM, or you can run on KVM virtual machine, or containers, or bare metal level. This NSX support for all the flavors. This NSX, just now we learned it providing a virtual network services. All these services are like switching, routing, firewall, IDS, IPS, load balancer, and web application firewall, service mesh, monitoring, and analytics. These all can provided within our NSX software. Suppose if we do not have NSX or no NSX in our environment, what will happen is, if you want to configure the network services, virtual network services for your VMs, for switching, we have to depend on Cisco vendor. Cisco switches is needed, or another vendor is Arista we have to use. And routing, we have to depend on Cisco routers or any other third-party external routers. And same way for firewall also, Cisco firewall or any third-party Palo Alto firewalls, and both firewall and intrusion prevention systems. And load balancing, we can use either FI load balancer or Citrix load balancer. And service mesh, we can use Red Hat or AWS app mesh. And for monitoring and analytics, for specifically for network devices, either we can use Cisco and NetBrain, any of the third party tool. This is in a virtual machines perspective. Suppose I have in my environment containers. Again, we have to go for the some more other tools like Flannel for a switching, for container switching, and routing. Calico we can use for containers routing, or we can use Open Virtual Switch software. And for the firewall, we can use Tigera and V works for intrusion prevention system, and for the application load balancing we can use HA proxy for containers load balancing, or we can use Nginx. And same way for service mesh also we can use Istio, Envoy and Linked. These all for a service mesh functionality for containers. And same way, if you want to monitor your container based applications, monitoring analytics, we have to use some other third party tools like Grafana and also the some of the other Splunk other tools. That is a point we highlighted here. Without NSX, we require separate hardware components and software components. But when we are using a VMware NSX, the benefit is all are within a full stack. It can be easily automated also. But when we are using a different products, different hardware and software within our network virtual infrastructure, what will happen is alternative solutions have gaps in the portfolio. Always there will be some gaps, and it's not like a greenfield environment, it's a brownfield environment. But when comes to NSX, it's completely a greenfield environment, and it will provide you the full stack is the only way to really provide complete automation. Okay, that is a benefit of using NSX and without NSX. So NSX supports VMs, containers and bare metal workloads, and full stack networking and security from data centers to cloud. Either you can run from on premises to cloud environments, private, public and hybrid. Okay. Now let's move on to the another key point. What is the common network infrastructure challenges and solutions with NSX and without NSX? Suppose the left portion is explain about without NSX, what is the challenges and what is the solutions with NSX. So the first key point here is application architecture complexity. Nowadays application architectures are keep changing, like architecture changing to the Kubernetes and microservices architecture, and VMs also. We can run either VM on tier based on virtual machine level, or you can run it as a Kubernetes architecture, or you can run it as a microservice architecture. For all these applications, it requires a storage. So for application architecture complexity, architectures are changing, containers and microservices. Networks are increasingly more complex and heterogeneous. Heterogeneous means different networks. And spend time learning tool set and platform. So most of our infrastructure team spend more time to learning all these concepts. That is a one key challenge. And another one, hardware based architectures are inflexible and expensive. Obviously hardware is always expensive when compared to the software. So hardware based cannot adapt fast. We cannot adapt. There will be some compatibility challenges, and inefficient, cannot scale out, expensive, cannot scale out also. That means we cannot add additional network devices immediately. It will take longer time, and cost wise it's a expensive, and it take days, weeks to provision, patch and upgrade. That is also one of the challenge in network infrastructure, physical network infrastructure. And another challenge, operational complexity. So for network, we have a separate network team. To maintain the security, we have a security operations team. So lack of operational agility and huge operational overhead of running such networks. And apart from this, we have a high capex, capital expenditure and operational expenditure for network infrastructure. These are all the challenges when we do not have a NSX. Let's say if we have NSX, what is the solution in the first scenario is when we start using the VMware NSX-T network virtualization security platform, it will help you to do. NSX-T offers an integrated L2 to layer 2 to layer 7 platform, so that VMs container all the NSX-T supported for all VMs container bare metal and across the environments, data center, and also to you can run on public cloud and edge clouds. And similarly, another solution for hardware, this one, NSX-T is 100% software based. So when you have a challenges with hardware based, better to change it to the software defined network. So NSX-T is 100% software based, must be delivered and consumed in software and built into the infrastructure, and policies applied granularly. Okay, and another solution, NSX-T offers automation and consistent policy. So when we are using a physical network, operation always complexity among the team members. But when we are using NSX-T, it's a software component. We can easy to automate, so create and deploy the policies in a consistent manner everywhere in our network and eliminate silos. So earlier we have a separate network team, separate storage team and security team. But when it comes to the NSX-T, both the network and security all are both are running in a same NSX layer. Now another network challenge, networking has changed challenge. So traditional networking is focused on hardware. Let's say in this diagram we have four switches, switch 1, switch 2, switch 3, switch 4. All the switches connected to the two core switches. So even core switch have a connection to all four switches, and second core switch have a connection to all four switches. But when we want to communicate to virtual machine, our virtual machines require a additional physical load balancer and firewall. Let's say in this diagram, we have a three virtual machine, one VM running with application, another VM also application, another VM running with a database application. If I want to establish a communication between one VM to our database VM, see one virtual machine, it goes to the firewall, it will verify the firewall whether the rule is allowed or not, and then it will check the load balancer IP. And if we have a load balancer IP, through the load balancer IP, we can able to connect to our database. That is a physical layer connection. That means we have a, if we want communicate from one app VM to DB VM, there is a three enforcement points, like one is switch, core switch, and also the load balancer firewall. These are all the enforcement points. And same way, if I want to communicate back to DB to our virtual machine, again the same communication. Let's say DBVM, let's observe the green line. DBVM first it will go to the load balancer DB, and DB to its again communication back to the application VM. This is the traditional networking, how it will works in the hardware layer. So that means our infrastructure, traditional networking is usually hardware based. The application is at the end of the chain. There are multiple enforcement points. This is the enforcement points. Operations, how it will operate is multiple handover between the teams, numerous enforcement points like firewall, we have a firewall, router, switches, load balancers. We have a switches and load balancer. Suppose if we here in this diagram we shown in a simple communication between app VM to DB and vice versa. If we have a different network, again in this diagram we have to include the router also. So that points I mentioned here. Routers also part of the numerous enforcement points. This is the challenge. Now let's try to understand how we're going to address this challenge with our NSX. So networking has changed. Solution is software defined network is built for the applications. Let's say within our application layer, we have app VMs and database VM hosted on VMs. These all running in a virtual machine. But instead of touching our physical network layer within our virtualization abstraction, we are added another abstraction layer that is called SDN, software defined network layer. It providing a main services, virtual switching, routing, firewall, and load balancer, centrally controlled and deployed. And also we have a physical network. Physical infrastructure work as a transport layer, that is our infrastructure layer. So now this application, how it will focus is application in focus, building a repeatable infrastructure for application, abstracts the hardware layer and virtualizes network layers, network resources. So operation is policy based enforcement based on the application behavior, either communicate between app to DB, vice versa. So enforcements at the application level, not at the multiple points in the infrastructure. So it won't communicate to the physical infrastructure layer. It will communicate within the software defined network layer. Okay, that is the importance of NSX. And another difference is within the security perspective, NSX versus without NSX. Let's say, let's talk about the without NSX. We have a traditional data center. So within a traditional data center, we have a perimeter firewall and we have multiple networks. See application VLAN for HR team, and there is a two VMs for finance team. Again, application VLAN from finance team and HR team. And internal firewall, the internal firewall also available for services management VLAN and also DB VLAN. We have two departments, finance team and HR team. But the firewalls are not for a individual VM. It's available centrally for all your workloads. That is in a traditional data center. But when it comes to NSX, the key part is micro segmentation. So we can implement the security at the each individual layer. The same diagram within our NSX-T, what we can do is for HR group, we can make application VMs and DB VMs and also the application, another web VM, app VM and DB, three tier VMs, and finance group also have three tier VMs, web VM, app VM and DB VMs. Apart from web, we also have DMG VMs. That means demilitarized zone VMs. And we have a separately services management and group service management. Same like traditional data center, we also have in a NSX data center. But only difference is instead of maintaining a internal firewall, when we are using NSX, the security can be implemented in individual VM level firewall. That is the benefit of using NSX. Okay, so isolation, segmentation. So enables the NSX enable the use of parallel virtual network that are fully isolated from other virtual network. So that means HR network is completely isolated from finance group network, and management network completely isolated from both HR and finance groups. Okay, but when we are using a before NSX, all are connected to same firewall. And segmentation means secure communication between workloads by implementing flexible policies that might mirror the application landscape. Okay, so this is the security at NSX layer. Now, how is VMware NSX licensed? Same like our vSphere, VMware vSphere is the server virtualization product. We have a licenses like standard, advanced, enterprise, enterprise plus. Similarly, our NSX also have the licensing mechanism. So VMware NSX is available licensing in multiple editions, standard, professional, advanced, enterprise plus, and robo. Robo means remote office, branch office. So in general, standard means with the basic features, advanced and enterprise plus means it comes with a advanced features. Okay, that is a main difference. But in detail of all the licensing features, I will cover in the later sessions. And NSX licensing, it's available as a single download image, one single image file only, with the license keys required to enable specific functionality for each edition. So when we download the respective enterprise license key, you will get all enterprise license key features. When you download the standard key, you will get only standard key features only. You won't get the enterprise plus features. That is the difference. Now, let's talk about what are the use cases for VMware NSX-T. So VMware NSX-T, if you are using in our organization, there may be some use cases where we can use the NSX-T. See, the main use cases for NSX include zero trust security. Zero trust is the key point, and multi-cloud networking. If your organization using a multi-cloud, for that layer, we can use NSX-T. And network automation. If you want to do automation in your virtual network, we can use NSX. And container networking and advanced load balancing, and also container ingress. Okay, these are all the main use cases. Let me elaborate these use case points now. So NSX-T use cases, if we highlight, main key points are security, multi-cloud networking, automation, and cloud native apps. Within the security, the main point here is NSX data center distributed firewall allows organization to achieve zero trust model by providing micro segmentation. And in a multi-cloud networking level, NSX allows organization to achieve consistent networking and security, and including all our workloads like on-premises, AWS, Azure, and other cloud vendors. And when it comes to the automation, NSX is a software component, so it's easy to automate. So NSXT provides network and security service in software completely decoupled. Decoupled is nothing but a disassociated or completely as a disassociated from physical network. It becomes easier to automate network and security deployment and configuration. And cloud native apps. So cloud native apps means here NSX can be used to provide network and security services for virtual machine, bare metal servers, as well as containerized applications. So container application is the booming technology. Okay. Now, until now, we focused on the NSX-T licensing, NSX-T use cases, and what will happen when we have NSX without NSX. Now it's the time to discuss what is the difference between NSX-V and NSX-T. Okay, so product comparison, NSX-V and NSX-T. As I mentioned, NSX-V full form is NSX Data Center for vSphere. NSX-T full form is NSX T data center. That means it's a network and a network virtualization security platform. T means transformers. Okay. And the difference point, first point is this NSX V means vSphere. So it's only for vSphere environment. It won't support for a other environments. If your organization have a private cloud with a different private cloud like Nutanix Calm, if your organization using a hybrid cloud, VMware cloud on AWS, if your organization using a public cloud, Azure or Google Cloud Platform, during that scenario, NSX-V product is not compatible. It won't support. But when comes to NSX-T, an independent network and security product. So this can be supported for all your workloads. Private, public, multi-cloud, on-premise, anywhere if you want to run, you can run the NSX-T. So that is the reason nowadays most of the organization, when if they are using NSX-V, they are started migrating to NSX-T. And NSX-V have a limited use cases and NSX-T have modern use cases. Modern use case means it's supported for all the modern application containerization security. And it supports only for vSphere VM workloads only. But when it comes to NSX-T, all workload types, that is VMs, container, public cloud and bare metal. And this NSX-V sunset period, no feature features, only bug fixes. That means NSX-V already end of support. End of support is this year January 16th, and it will VMware providing a technical guidance only until the next year 2023 to January 2023, and later on NSX-V is completely a outdated product. So that is one of the main reason companies are, because this product is end of support, so they have started migrating to the latest product, which is NSX-T data center. And NSX-T data center, it also have a so many advanced feature when compared to NSX-V, and mainly it's supported for all workload types. But in the NSX-V, it's only for VMware vSphere virtual machine workloads only. Now here, NSX-T is healthy roadmap with hundreds of new features, not only limited to some features, it have a hundreds of features. Now, let's talk about the NSX-V sunset period information. See, product lifecycle of NSX-T data center for vSphere. Officially, VMware says that sunset period end of general support is this year, January 16th, 2022. But still VMware provide a technical guidance. If any existing customers they are using NSX-V, they will provide some technical guidance only. There will be no additional security patches. Okay, but the technical guidance also until the next year January 16th, and the customer must not deploy a new NSX-V deployment. Suppose you are when you are having a customer conversation, if any of your new customer interested to move it to the virtual network, like they want to introduce an virtualized network or network hypervisor, instead of recommending the customer to go with NSX-V, start recommending with NSX-T only. Okay, that's point we highlighted here. Customer must not deploy a new NSX-V deployment. All new deployments must be with NSX-T. NSX means network security platform transformer product. Okay, and this is a best picture for sunset. So NSX-V also going to the sunset. It's going to expire. Already expired, but guidance also will expire by 2023. And this exact date information we can find it from the VMware website. So I just captured the VMware website screenshot. If you see the product releases general availability end of support guidance document, we can see NSX data center for vSphere 6.4. See, this is the end of general support date 2022 January 16, and the technical guidance also 2023 116. As per this document only I mentioned in the slide. And when we see the latest version of NSX-T 3.x, we have until 2024 and technical guidance until year 2025. Okay, and even the previous version of NSX-T 2.5 also already expired. Technical general support and guidance we have until this year September 19th. Okay, this is how we can verify. Even if you want to extract this document, just go to the VMware website and search with the product lifecycle matrix. You will get this document. Okay, you can extract this information to PDF or Excel format. That is how I captured and I pasted here. Now let's talk about architectural comparison between NSX-V and NSX-T. So what is the difference in NSX-V architecture and NSX-T architecture? See, in architectural comparison between NSX-V and NSX-T, the left side portion is explained about NSX-V, NSX data center for vSphere, and right side diagram is explained about NSX-T data center. So let me explain the NSX-V architecture first, and then I will explain you the NSX-T data center. But in this architecture, if you refer here, all will be in a 4-layered architecture. The first layer is physical network. Even though if you are using a network hypervisor, still we need a physical network. So that is the first layer. And second layer talks about the data plane layer. And the third layer is talk about the management plane and control plane layer, and fourth layer talk about cloud management platform. Let's say in our NSX data center for vSphere, the first cloud management platform means it is mainly used for a user access and user interface, mainly to connect to the NSX infrastructure, and it will also help you to do the automate cloud management platform. And come to the second layer, when we are using a NSX-V, we have a it compulsory vSphere means it's require a vCenter server. vCenter product is compulsory, and NSX manager can run on a vCenter as a virtual machine. And within NSX manager, we also install a NSX controller. This is a 3 virtual machines. This 3 virtual machine we consider as a NSX controller cluster. So that means if you want to configure NSX, we need a totally 4 virtual machines, 1 VM for manager and 3 VMs for controller cluster, and another VM for NSX logical routing controller VM. This is also needed, and another VM for NSX edge service gateway. This edge service gateway, minimally we can configure 1 or 2, and one for a internal NSX edge service, and another one for a external edge service, or one for a management and another one for a application workloads. So, but in the management and control plane, these are all the main key components in NSX V. And when it comes to the data plane, we have a NSX Edge Service Gateway, and the main encapsulation protocol in NSX-V is VXLAN. VXLAN means Virtual Extensible LAN, and DLR means distributed logical router, distributed firewall, and vSphere distributed switch. Even in our ESXi host, we have a DV switch, and physical network is common. This is the main architectural components in NSX-V. Let's understand the NSX-T. And NSX-T also have a physical network. Still, we need a physical network, and compute cloud management platform for the user automation and all. We need a CMP platform. And comes to the management and control plane, this is the main architectural differences here. When you see the NSX-V, we have manager, 3 controller VMs. But when comes to the NSX-T, these components are combined here. See, within our one virtual machine is running with manager and policy role, control role. And another manager also required manager and policy role, control role. And a third NSX manager and policy role and controller role. That means instead of using a 4 virtual machines, VMware re-architectured in NSX-T, and they make it as a 3 NSX VMs. One NSX VM combined with manager and controller, another NSX manager combined with manager and controller, manager with combined and controller. But in our previous edition, controller is separate 3 VMs, manager separate VM. But when comes to NSX-T, both are combined. That is a architectural difference. And here in our NSX-V, we require a vCenter, but in our NSX-T, without vCenter, we can run the NSX manager. That means it's completely a independent product. And comes to the data plane layer, even within the data plane layer, in our NSX-V, we have NSX Edge Service Gateway, in short form ESG. But when it comes to the NSX-T, we have NSX Edge Transport Node, ETN. That is the naming. The naming convention is changed. And in our vSphere, we require a DV switch in NSX-V, but in NSX-T, we have to use NSX distributed switch, that is called NVDS or VDS. And our encapsulation protocol in NSX-V, we have VXLAN, virtual extensible LAN. But when it comes to NSX-T, this encapsulation protocol is enhanced. It's changed to GenEVA. GenEVA means generic network virtual encapsulation. This is the advanced encapsulation protocol. When compared to VXLAN, GenEVA have some additional features, and all those additional features we'll discuss in the following sessions. And the DLR, distributed logical router, even this DLR also, when comes to the NSX-T, it's split into the two DLRs, tier 0 gateway, tier 1 gateway. Earlier we talked about tier 0 and tier 1. Tier 0 gateway mainly for north south connectivity, and tier 1 gateway mainly for east west connectivity. East west connectivity means within our logical switches internal communication, and tier 0 gateway means for external communication, that is north south connectivity. And DFW is similar to NSX-V. We also have DFW here. And only the naming convention earlier is edge service gateway. Now this naming convention changed to edge transport node. Normally the benefit of NSX edge is, if you see in this diagram, it's provide you a routing services. The icon is routing. It's provide you the firewall service. It provide you additional VPN service. It will provide you a physical to virtual connectivity PV, and it's provide you a load balancer. When you install the NSX Edge only, will get all these features. And same way, when you configure an Edge NSX Edge transport node, we will get all these features: T0 gateway, Tier 1 gateway, DFW, and all. Okay, this how NSX Edge configure and all, I will show you in the upcoming sessions. And physical network is still common for both NSX-V and NSX-T. Okay, I repeat, one key point for architectural difference is, in our NSX-V, manager and controller are separate virtual machine. When it comes to NSX-T, manager and controller is combined within a one VM. That is one common architectural difference. Another difference is, in NSX-V, encapsulation protocol is VXLAN, and NSX-T encapsulation protocol is GenEVA. And third difference is, in NSX-V, NSX Edge is configured as Edge Service Gateway, ESG. This terminology changed in NSX-T as NSX Edge Transport Node. That is the main three architectural differences points. Okay. Now there are some additional differences I will show you in the following slide. See, NSX-V and NSX-T. Environment support. Normally, as I mentioned, NSX-V is best suited for on-premises workload. NSX-T supports multi-clouds, multi-hypervisor environment, bare metal workloads. It also supports cloud-native applications. And Kubernetes support. Kubernetes support, no support for Kubernetes with NSX-V, but NSX-T integration with Kubernetes through NSX-T container plugin. One plugin we have to install, that is short form is NCP. And migration path. If you want to migrate your environment from NSX-T to NSX-V, it's not supported because V is already outdated. It won't support to revert to the NSX-V. But if you want to migrate your environment, VMware has built an NSX-V to T migration utility in NSX-T. We have a default migration coordinator tool. Using the tool, if you want to migrate from V to T, it's possible. And MTU value. MTU means maximum transmit unit value. So MTU value minimum 1600 or higher is for VXLAN, virtual extensible LAN, and MTU value must be at least 1700 bytes when using a GenEVA encapsulation. GenEVA means generic network virtual encapsulation. And NSX edge deployment, we can deploy on ESXi VM, and NSX-T edge deployment, we can run on ESXi, or you can directly run on a physical server. and overlay encapsulation protocols. So protocol, just now we talk about VXLAN, NSX-V uses VXLAN and encapsulation protocol. Genevieve NSX-T uses Genevieve, which is more advanced protocol. And physical network assignment, physical NICs are not owned by NSX-V, they are assigned to the virtual distributed switches. And physical NICs are owned by NSX-T, transport node, and assigned to NVDS. That means network NSX virtual distributed switch. And routing terminology, in our NSX-V routing terminology is DLR for east-west traffic, edge service gateway for north-south traffic. But in the NSX-T, tier 1 logical router for east-west traffic and tier 0 logical router for north-south traffic. East-west means intranet communication, north-south means external communication. And tight integration with vSphere, yes, and NSX-T is not a tight with vSphere, you can run anywhere. And transport zone types, we have only one type of transport zone in NSX-V, and in NSX-T, two types of transport zones, that is overlay transport zone, VLAN transport zone are available with NSX-T. And two-tier distributor routing not supported, but in the NSX-T, two-tier distributor routing is supported. That is tier 0, tier 1. And virtual switches, NVDS used, virtual distributed switch. And here NSX-T we can use converged VDS, in short form VDS also we can say, or we can use open virtual switch. And working without vCenter, NSX-V cannot work, but in the NSX-T, without, it's not dependent on vCenter, without vCenter also we can work. Okay, this is the high level overview of what is the main difference between NSX-V and NSX-T. Okay, now let's talk about what are the migration options from NSX-V to NSX-T. See, in migration options, we have three migration options, NSX-V to T. The first one is migration coordinator, and second one coexist, and third one is lift and shift. And why should I learn these migration options? Let's say when we having any customer engagements, when we are conversating with your networking team, or when you have a conversation with your new customers or existing customers, if they are using a NSX-V network, NSX network infrastructure for vSphere platform NSX-V, it's already, as we discussed, it's already going to expire technical guidance by next year January. So customers are have to migrate the NSX-V infrastructure to NSX-T. So that time customer definitely they will ask, as a solution engineer, we have to respond to them, what is the migration options available from NSX-V to T. So that scenario, it will be helpful not only for your customer conversation, even in the interview perspective also. One of the most important interview question in nowadays, when you are attending for any network virtualization engineer position or solution architect position, they will ask, what is the migration options from NSX-V to T. During that scenario, you can explain these three options. See, the first option is migration coordinator, and second option is coexist, third option is lift and shift. Let me explain the first option. So first option is fully automated migration. Example, I have one house, time to remodel or renovate. That is the migration coordinator. This migration coordinator comes with a NSX-T. Within NSX-T, using the migration coordinator, you can easily migrate NSX-V to NSX-T. And coexist, even if you see the diagram, we have a two in a within a infrastructure. So that is called coexist. NSX-V and NSX-T side by side, we can run our infrastructure, and the new project, no urgent need to consolidate. We can slowly move all our resources from V to T. That is a coexist model. And I have one house need to rearrange. That is one just example for easy understanding. And third migration option is lift and shift. That means completely two different environment. We have to lift our NSX-V components and shift it to NSX-T environment. So move VMs greenfield NSX-T. So lift and shift is mainly for a greenfield, and coexist is like there is some expected minimal downtimes. So that is the reason coexist is considered as a brownfield migration option. Okay, so here example is, I have two houses with plans to move to one house. That means removing old house, keeping in the new house. Okay, and let me elaborate this migration options in the following slide. See, this is a high level comparison of migration options, migration coordinator, coexist and lift and shift. Let me explain the migration coordinator first. See, the migration coordinator, the new hardware, yes, but the new hardware is only minimal hardware only. No need to maintain a multiple hardware device, only minimal. And outages, when we are using migration coordinator, the outages are very minor, minimal outage, that is a negligible outage, like north south 10 to 30 seconds, and in place east to west traffic 5 to 20 seconds. So it's a kind of negligible downtime, very minimal downtime, and the same as vMotion only. Migrate the VM same as VMs. Virtual vMotion means migrating the virtual machine from one host to another. How we migrate the vMotion VM? Same way you can migrate the VMs from NSX-V to NSX-T. And automated config migration, yes, using migration coordinator, it's automated migration only. And multiple configs to manage NSX-V NSX-T, no, we no need to do any of the configuration changes. It's a completely automated only. And rollback plan, suppose when we migrate the VM from NSX-V to NSX-T, your customer may experience some network outage. So immediately your customer called and he say, I don't want the NSX-T at present because there is some application outage. Immediately, can you revert to the NSX-V? So that rollback plan still is possible in migration coordinator. And compatible with CMP. CMP means cloud management platform, which are the current available VMware cloud management platforms are VRA, vRealize Automation, vRealize Orchestrator, and vCloud Director. These three are the cloud management platforms. Suppose our customer is using any cloud management platform, this migration coordinator option is not recommended. That means it's not supported also. So when your customer is having any cloud management platform, this migration coordinator method is not recommended. Suppose if your customer is not using any cloud management platform, we are good to use the migration coordinator method. Okay, now let's talk about the second method, coexist method. Coexist method means new hardware is not required, because coexist, that means existing within vCenter. When you have available resources in any one of the cluster, in that available resources cluster you can deploy the NSX-T environment. When you install NSX-T environment, there will be no outage. New VMs deploy to T and old VMs left on V until they age out. So we haven't migrated. We just deployed NSX-T also in the same environment. And automated, no. Admin must maintain both V and T configuration. There is no automated configuration migration. And multiple configuration to manage V and T. Yes, we have to perform the manual migrations configuration changes. And rollback plan, one drawback in the coexist model is not available. Rollback plan is not available. That means, suppose I have migrated some group of 10 VMs from NSX-V to NSX-T. Once I migrated to NSX-T, if your customer have some intermittent network disconnections, customer want to roll back from NSX-T to NSX-V. When you already migrated using coexist method, definitely rollback option is not possible. So that is a drawback in coexist model. And compatible with CMPs, yes, even the coexist model is compatible with cloud management platforms. But some of the customers, they are unhappy with the no rollback plan. But the coexist model is considered as a brownfield NSX-T environment. Only some customers, if they don't want to invest on additional hardware, they may go for coexist model. And the third method is lift and shift. So lift and shift new hardware, yes, some extra capacity during the migration. Definitely it requires some extra capacity. Suppose in our vCenter server, we have a 4 clusters. One cluster for management, one cluster from web server, one cluster for app server, one cluster for a DB server. I have totally 4 clusters. That means one management cluster, 3 workload clusters. If you have 4 clusters, if you want to deploy an NSX-T environment, equivalent vCenter clusters we have to deploy separately. That means we need to buy a new hardware. If your 4 clusters have a minimally each cluster have 10 hosts, that means 4 cluster means 4 multiplied by 10, 40 ESXi host. But when comes to the new environment, at least minimally we have to buy each cluster minimally 3 nodes. So 4 into 3, 12 nodes we have to we require in a new NSX-T environment. When we have at least minimum nodes, start migrating NSX-V VMs to NSX-T, and later on, when the resources are free from our old infrastructure, those ESX you can remove from NSX-V and add that ESX to new environment. That means overall lift and shift method still we require some extra capacity during the migration. That is only the extra cost in lift and shift, but the benefit of lift and shift is it's supported for your cloud management platform, and rollback plan also available, and the lift and shift method is a greenfield environment. But only thing to your customer is there will be some extra capacity customer has to buy. Okay, and outages, definitely there will be no outage. It's almost like vMotion. Even in our migration coordinator there will be a minimal outage, but in the lift and shift method it's completely a greenfield environment, smooth migration. But only challenge in our lift and shift is customer has to purchase additional hardware. Okay, and automated config migration, no automation, manual scripting is required. And multiple configs to manage NSX VNT, yes, we have to maintain the all the configuration information. So here manual scripting means suppose you have a 3000 virtual machine. If you want to migrate 3000 VMs from NSX-V to NSX-T, we have to right click the all VMs 3000 times. Instead of doing manual migration, what we can do is we can use a PowerCLI scripting using move VM command. You can prepare a short script for your all virtual machine migration, and you can map all our VMs in a CSV file and start run that script. It will start migrating all your virtual machines from NSX-V to NSX-T. So manual scripting only available. And rollback plan also available in lift and shift, and it is also compatible with cloud management platform. If your customer is using cloud management platform, better to go with a lift and shift model. Okay, so each this is about the NSX V to T migration comparisons, but most of the time depends on our we have to present these options to customer. So it's a customer's choice. If the customer is ready to buy minimal hardware, they can go migration coordinator. Again, the condition is if the customer do not have CMP only, we can prefer migration coordinator. Suppose if your customer do not have any budget to buy a new hardware, we should mention the coexist model, but also inform to the customer one challenge is there is a no rollback option. Once the VM migrated to T, it cannot be rollback. That is a drawback in coexist. That is the reason we also mention coexist is a brownfield environment. But when comes to lift and shift model, rollback option is available, and even if your customer is using cloud management platform like VRA, VRO, and VCD, vCloud Director, still we can use this method, lift and shift method. But only challenge in this method is customer has to buy some extra hardware. I give an example. When we have a 4 ESXi host, we have to buy a minimally 12 ESXi host. Suppose if you have a n number of clusters, depends on your n means any number. Let's say you have 20 clusters. 20 clusters, minimally each cluster we need a 3 nodes. So 20 into 3, minimally we have to buy a 60 ESXi host. So that's how we can given the solution to customer. When we start small with the cluster deployment to NSX shift environment, then you can easily lift and lift the VM from NSX-V and shift it to the NSX-T. Same like vMotion migration. Okay, hope you understand the NSX-V to T migration comparisons. So that's it for today. Thank you. And thanks for watching. Thanks for your time, and thanks for all your subscriptions. Please do view, like, share, and subscribe to my YouTube channel, Nine Cloud Garage. Bye for now.